On the afternoon of September the 19th, 2021, an eruption occurred at the Cumbre Vieja volcanic ridge on La Palma. It is the longest and most damaging volcanic eruption of the past 500 years, and a rare chance to experience Earth's history in the making. Bravo is part of a group of volcano experts whose task it is to assess the danger posed by the volcano to the population. The volcanic crater is located above a densely populated area on the west side of the island. It is the second day of the eruption.
It's impressive how big they are. It's incredible that a pyroclastic rock of this size can reach such a spectacular height. Wow. It's as if cars would fly. But it's not so heavy, right? No, it is. Of course it is. It petrifies in the air and becomes a volcanic bomb as it cools. And it has an enormous density. It's like watching a car or a truck fly through the air.
The fear of large-scale destruction of inhabited areas is increasing. On the second day, lava has already flowed over 180 houses, and the volcano is spewing out more and more material. Driven by gas explosions, pyroclastic rocks are hurled up to 300 meters in the air.
Now we are keeping an eye on the direction of the lava flows. So all these people is trying to find out what is the path or the way of the lava flow towards the sea. It depends on the way, it depends the amount of houses are going to be affected and the people that are going to be affected.
The material of this volcanic ash comes from a depth of 40 to 50 kilometers. The volcanic processes have transported it upwards with gaseous magma. Particles are thrown into the air with each explosion as gas is released, forming a column as high as 3 kilometers.
All these houses have been evacuated, and as you can see, we have volcanic ashes covering the road. This is probably the most recent soil in the world at the moment, because it's all these ashes we can see in that plume, in that column, are flying away, and the thicker ones are falling down on the ground. You can see all these volcanic ashes that have been falling down for the last couple of days. So you can see it's deep, it's quite deep. So the amount of material that is falling down is a lot at the moment, so because it's covering the whole road.
Many millions of years ago, driven by the Earth's inner core, hot magma flowed upward and penetrated the Earth's crust. No one knows how many eruptions followed, until the lava piled up enough to reach the water's surface from 4,000 meters below at the bottom of the ocean. La Palma was born, a block of lifeless volcanic rock in the middle of the Atlantic Ocean. Over the past 2 million years, it has evolved into a green island, La Isla Verde, one of the steepest islands on Earth.
They rise to such an impressive height.
Impressive? They fly more than twice the height of the column seen over the crater.
Breathtaking.
We are going to, because it's too much gas, you can see sulfuric acid, so the activity of the gas is increasing, and it could be poison for the people. So whenever you smell it, we should move. being witness of how the environment, the Earth, is able to create new material. We are watching that the volcanoes create territory, they create ground, and we are being witness of the power of the nature creating, but we are also witness of how the nature, the environment, the volcano destroy.
When large amounts of magma press against the Earth's surface, huge layers of rock start to move. Pablo González, a volcanologist from Tenerife, and Edgar Zorn and Alina Shevchenko from the German Research Center for Geosciences are particularly interested in changes in the island's surface. Fractures could indicate possible instability of the volcanic structure.
This eruption, for good or for bad, is the type of eruption that was postulated to be a possible trigger for a collapse. So we are here to test this hypothesis. We want to put instruments that they can record if any movement will happen.
That could have drastic consequences.
We bury a tilt meter, which is a sensitive inclinometer, wherever we see movement in the mountainside. For example, when there is a magma intrusion, the surface tilts. We can track that here with our instruments under the earth, and then we can see when and how and in which direction the slope is tilting.
There are a special type of volcanoes, intraplate hotspot volcanoes. Canary Islands is one of these very special and different type of volcanoes. They are characterized from growing very, very fast. Those volcanoes increases its size, so much so that its base is not expanding and catching up. So big with a little base means that this material could be unstable.
Not far from the eruption site, the emergency workers have established their base. This is where the evacuation is organized and the coordination of research groups happens.
Nunca me molestan, nunca me molestan. No. Sí.
Manuel Nojales has been researching the flora and fauna of the Canary Islands for 40 years. With his colleague, Felix Medina, he moves around the volcano to study animal behavior and the effects of the eruption on plants.
My last days has been a little bit complicated. You know, we are dedicating a lot of hours in the field, doing field work, monitoring the volcanoes. Practically we are sleeping 3 hours, 4 hours per day during the last week because we need information, you know, in order to manage, you know, the situation as best we can. And I try, you know, to study a little bit from the environmental point of view. Practically no study has been published, no information has been, you know, put in the knowledge of the people, you know, about what's happening with the fauna, what's happening with the flora, you know, with an eruption, one volcanic eruption is occurring. Bueno, fíjate que tenemos los dos planos.
Manuel Nojales and Felix Medina have marked various research areas around the volcano. Originally, there were 45 individual places that they wanted to visit every day. But the volcano and its lava fields have already cut off many of these places, flowed over them, or made them inaccessible to the researchers. It's not easy to do research when the area is buried under 1,000-degree lava. Nogales and Medina observe birds and lizards, writing down their occurrence and behavior. Their study will examine how nature evolves during and after an eruption. To what extent will the volcano change life on the island? Which species will survive the catastrophe?
We are keeping in an eye on the lava flow, because we are thinking that this lava flow is going towards the cliff over there. So it's going to go down, and it's going to go to reach a place that is completely full of houses.
Lava is erupting in at least 7 places on the volcano. At times, several lava flows push their way down the mountainside at speeds of 120 meters per hour. Whatever is in their way is destroyed. In the meantime, 5,000 people have been evacuated. The lava flows pile up to 6 meters high. At the end of the eruption, they will be 60 meters high in some places, and 1,200 hectares of land will be buried under them. A good month after the eruption, the pine forests on the western slope of Cumbre Vieja are massively struggling with the effects of the volcano. Ash has settled on the plants and impaired photosynthesis. Manuel Nogales and Felix Medina find seed capsules full of ash.
Porque aquí lo único que hay prácticamente es ceniza, nada más. Aquí no hay. Fíjate la caída de Pinocha.
This loss of needles is relatively new. It's been going on for 5 days now. You can write that down. October the 25th, 2021, massive needle drop in pine trees, probably due to aerosols that kill the needles. This is absolutely not natural.
The heat and acidic aerosols are taking their toll on the pines.
The trade winds, which are the predominant ones, always come from the northeast. This means that the plume is often blown to the southwest, and that is why those trees are so affected.
Close to the new crater lies the lava field of the San Juan volcano, which erupted in 1949. Over the decades, lichens have settled on the normally inorganic volcanic rock.
We are trying to uncover some lichens covered by several centimeters of volcanic ash that has rained down over the last few days. Life goes on under the volcanic ash. The lichen colonization takes place first. They are the first organisms to colonize the recent lava flows. They are the key to the decomposition of the rock substrate, and over a very long period of time, they transform it into soil substrate, so that after many years, other plants can colonize the lava fields.
A canary gecko has sought shelter among the boulders.
In fact, just a few days ago, we found some animals that were completely disoriented close to these exact plants. And obviously, they can't find food because practically all plants have perished. It is a desert in which the animals wander around and in which survival becomes close to impossible for them.
You have ash on the new colada flows, okay? Sí. Mantenga ahí. Ahora,
A uno, sí.
Ah, está
Subiendo
bien.
a uno, sí.
Me parece que está completamente seco. Dio la vuelta.
Over there, you can see some lizard tracks.
Y debió de ir a esas plantas.
It must have run to those plants to look for
Pero
food.
como se puede ver, la vegetación está
But as you can see, the plants are in very bad shape.
de las cuales se alimentan.
There are practically no leaves for them to eat. And if the lizards, which are food for other predators, can't eat, then we're probably witnessing a disruption of the entire food chain that exists here in the area.
Que está presente aquí en el área.
Volcanoes have been erupting on La Palma for millions of years. Although you would not expect any life in such an extreme location, thousands of species populate the island today. Its deep ravines and the differences in altitude up to 2,500 meters, La Palma has a number of different climate zones. And where living conditions are diverse, different plants settle and adapt. Hundreds of island endemic species can be found on La Palma. The only comparable biodiversity exists in Hawaii. Some claim that here you can watch evolution at work. And so, La Palma is considered the Galapagos of Europe among biologists. But how is it possible that life forms on the inorganic lava fields at all? Professor Severin Il is researching the development of biodiversity. He wants to know what strategies plants develop to adapt to environmental conditions.
Growth height 24 centimeters. Chlorophyll content is 57.0. Leaf width is 1.310.
On La Palma, Il researches natural recolonization after the eruption of Tanegua 50 years ago. The dark fields of inorganic material appear hostile to life. Nutrients that are actually present in the volcanic rock are initially trapped inside. All the more surprising that life is able to form here at all.
We have ferns and lichens, and also taller plants like this one that act as pioneer species. And they start the process of succession by bringing in organic material. You can already see it here. The leaves are falling to the ground, therefore leaving organic material. The roots are also slowly breaking up this very hard volcanic rock, and through that they release the nutrients that are actually present in this volcanic rock. Volcanic soil is actually relatively fertile, but the fertility here is not accessible to most plants for now. And it needs these kinds of pioneer plants that initiate the soil formation and prepare the soil so that other species can settle here.
The processes of recolonization can take millennia. One would need to travel through time to study significant changes in lava surfaces. Severin Il takes a different approach. Instead of traveling through time, he travels across the land, visiting lava fields of different ages. The development of 370 years can be studied at the St. Martin lava flow. Here, over nearly 4 centuries, pioneer plants have encouraged the development of life.
Up here is the volcanic ash of the young volcano, which is very dark black, and down here is the brownish soil. So a soil formation has already started. The brown color indicates that there is humus in the soil, and humus is an organic soil substrate. This means that organic materials have been introduced and the formation process has been initiated.
The basis of life for other species is established. The more species are created, the more growth takes place in the fields. The more intensively life spreads, and the faster an increasingly complex ecosystem develops.
So it doesn't really look like it now, but we are on a lava flow, one of the older lava flows here in the south of La Palma. It's about 3,200 years old, so much older than the other lava flows that we have visited so far, and we can already see that something has changed here. We're in a pine forest. It's much softer and gentler here because of the soil process, and also because of the litter layer, so it looks significantly different, significantly more evolved than the lava flows that we visited before. And it's now blending in more and more with the surroundings, so it's almost indistinguishable from the surrounding vegetation. The volcanic eruption is both destructive and creative. It is both. It destroys what was there before. It creates new land, new earth, new surface, which nature then reclaims.
On the 10th day of the eruption, the first lava flow reaches the Atlantic Ocean. When the orange glowing lava meets the cold, salty seawater, explosions can occur, and gases mixed with hydrochloric acid are produced. The lava penetrates the ocean to a depth of up to 400 meters and forms a delta half a kilometer wide, expanding the island. Marine biologist Sarah Gonzalez is diving approximately 20 kilometers further south. She compares living beings within and around a very special region. The undersea lava delta of Tenegua, which erupted in 1972, allows her to peer into the future.
Due to the volcanic activity on La Palma, the groundwater is full of CO2. The groundwater flows into the sea and changes the chemistry of the seawater. It is very acidic. In a way, we can expect the seas of the future to be like this because of climate change.
que esperamos que sea como el futuro debido al cambio climático. Entonces,
it's interesting to see how this acidification affects the invertebrates, fish and the algae that live here.
A los peces y a las algas que viven aquí.
Fuencaliente Beach is already hosting conditions that biologists anticipate the world's oceans to experience in 50 to 80 years due to climate change.
The species of sea urchins that we can find here resemble sea urchins in other places, but they are much smaller. Also, in the lab, we noticed something strange. They have a much more robust shell. Why is that? They need to protect themselves from these extreme environments.
Pero lo hacen para protegerse de estos ambientes tan extremos.
There has been an evolution, an adaptation to this acidified environment.
This volcanic zone is already enabling researchers to study changes in marine communities that may occur in 80 years. Here, it is possible to observe how species develop under pressure.
This place is very interesting because these lagoons were formed after the eruption of Tenegua. In these lagoons, the salt water from the sea mixes with the fresh groundwater, giving it very beautiful colors and special chemical properties. Due to the volcanic activity on the island, CO2-rich gases flow into the lagoon and acidify the water. An extreme environment has been created. Very, very extreme. Nevertheless, there are animals that live here. Among them, some worms and snails.
They live in water so acidic and brackish, it should destroy their shells. And technically, there is no food for them here.
Look at the fireworms. They are really special. This is the exact species that exists in the sea. But here in the lagoon, it survives in a new, very acidic and extreme environment. There are probably only 2 or 3 individuals that arrived here from the ocean, but they found an environment in which they quickly divided and reproduced. That is the perfect condition for a new species to emerge from an existing one, because the 2 populations occupy completely separate habitats. So maybe in the future we will have 2 species, one in the lagoon and one in the sea, an example of evolution.
Rafael Garcia Becerra is an entomologist. In the 140 lava caves discovered so far on La Palma, he looks for life that exists underground. Caños de fuego is what the locals call lava tubes like these. They form during an eruption when the cooler surfaces of the lava flows solidify and the hot lava inside continues to flow away.
Crazy amount of water. In the past, the locals from the Mazo area used to come to this cave every day to get water. It'll be difficult to see invertebrates. Over there, no. Maybe further down. The ground won't let us here.
Yeah.
Yes, is there no soil? There is, but it's rock hard. Crystals. There might be some life in this soil.
For 30 years, Rafael Garcia Becerra has been studying species that have adapted to the darkness of lava caves.
Troglofauna are very rare in lava tubes. Therefore, it is really hard to spot them.
The species that live here don't encounter any light, and they find hardly any food.
No se ve ni una arañita. Eso suelen ser de las que aparecen muchas veces en las
pruebas. They are energy savers. They have to save energy to the maximum because there is nothing here to get energy from. They save energy for the development of eyes, for the growth of wings. Their existence is reduced to the most necessary functions, and they have really completely slowed down their metabolism, so they end up living 5 times longer than similar species outside the cave.
Wow. A ver aquí.
Over millions of years, volcanoes have created a wide variety of habitats on this relatively small island. The necessary adaptation to new habitats favors the formation of new species. Thus, La Palma became a hotspot of biodiversity and a true laboratory of evolution.
If Darwin had traveled to the Canary Islands, his theory of evolution probably would have been based on his observations and findings here.
From the highest point of the island, Roque de los Muchachos, you can watch how the ash cloud of the volcano pierces the cloud cover. Between Todoque and Las Manchas, Jaime Coelho Bravo and his colleagues visit a new lava flow. They do this every day. Lava is not always the same. Geologist Raquel Herrera is able to read it.
Vamos, es del estilo de las que hemos cogido hasta ahora. Jo, es súper cristalina.
It's very crystalline. Look how many crystals it has.
Qué pasada, ¿eh?
Awesome.
Súper cristalina.
Super crystalline.
Hombre, claro, ten
Careful.
cuidado, que queman.
You might get burned. If you touch this, you'll burn
Te
yourself.
quemas, pero si la tienes un rato en la mano, sí te quemas.
Estamos visitando
We
una
are standing on a lava flow that formed earlier today.
formó esta mañana, esta zona
Its edge has been right here since this morning.
fluyó por aquí esta mañana.
Sí, la idea es ir muestreando.
The
cada
idea
lava
is to
que
take
sale.
samples from each emerging lava flow to see how their composition changes. We want to analyze whether the magma had previously accumulated in a chamber or whether it has risen directly from greater depths. Some minerals are only formed this way in magma chambers.
The composition of the lava is the key.
Tiene muchísima escoria.
Tiene mucha escoria, ¿no?
Look how crystalline it is.
Es por aquí.
And how much?
Claro, es que es totalmente cristalina.
Yes, it is very crystalline.
Sí, se ven los olivinos.
If you look closely, you can see olivine minerals. They are green or black because they have just emerged. It's not very easy to see them, but they're sparkling.
Pero brillan. Sí. Estos son
These are
más
smaller than the others we saw this morning, but the rock is full of them.
Yes.
Esta mañana veíamos unos olivinos más
This
grandes.
morning we saw some larger olivine
Y estos son más
minerals.
pequeñitos.
These are smaller.
Esta se ha enfriado más rápidamente que la
That
otra.
means
La otra
in the other
probablemente
sample, the
los
olivine minerals must have already crystallized long before the
olivinos
outburst.
los saca. Y estos no.
These, on the other hand, are not
En
so
teoría, en
crystallized.
principio, saldría
In
más
theory,
rápido.
this means that this magma rose to the surface without stopping. These tiny crystals here may have formed only recently,
Hace muy poco tiempo,
or at a shallower depth.
a menor profundidad.
The magma that came out today had not been in a magma chamber, or at least not for very long.
Lo que con esos minerales de anfibos.
On the other hand, the amphibole found in the first lava flows and the absence of olivine minerals tell us that the magma of the first days probably stayed in a kind of deep chamber for thousands of years.
Parado en profundidad en algo parecido a una cámara.
There are researchers who therefore claim that there must be several magma chambers, one located deeper and one a little higher, one about 8 kilometers below Earth, the other 15 to 20 kilometers.
What goes on in the depths below the Earth's surface? What does it look like down there? And how does magma reach the surface? Pablo Gonzalez has made a strange discovery.
Today we visit a fracture field that opened between the 3rd and the 4th of December. Recently, this fracture field has been used by lava to come close to the surface. This is something I was not expecting at all. We are 3 kilometers from the main eruption site, very far. And magma has been coming beneath the volcano and coming and erupted in this location. So this fracture system that is not aligned with the main one has to have a specific physical reason to appear. It should be part of the weakening of the volcano. It's using this magma weak lines in the volcano that were not used before. So it's informing us that the volcano is in itself heavily fracturated and weak in certain directions.
The fractures are clearly visible from above. Volcanic gases flow through the cracks.
I'm going to draw here La Palma Island. La Palma Island has a northern side that is inactive and the southern side that is Cumbre Vieja. Cumbre Vieja, as you can see, the island is pointing like an arrow, has a line of weakness along this arrow, this lineament. And most of the historical eruptions happen in this part and along using these lineaments. This eruption just happened in this location and in a certain angle. This is relatively unusual. But what is extraordinarily unusual is the fact that the cracks that we saw today were in this location, in this direction. As you can see, it's almost in a right angle with respect to the traditional direction of weakness of the island. In 1949, that fracture system displaced a block closer to the sea, 4 meters, downwards and towards the sea. Now, the present activity opened the question, is this block is going to move?
The volcanologists will install more measuring instruments around the volcano.
So we are roughly at 500 meters from the active vents, and this new location allows us to get more sensitivity measurements by being and putting the instrument closer to the volcano.
This is a data cube. It's part of the tilt meter. It's connected with the solar panel, and it basically records all the data and stores it.
Geophysical data, that's the most precious treasure for us.
I don't know, you have to find some of the smaller ones probably.
Alina, can you put it inside the box? We place geophysical instruments that are able to record teeny tiny movements of the ground. Why? Because if there is any reaction of the volcanic activity to the fact that there is this crack system, it will be expressed as little shift towards the coast. In the way up, magma can either create its own path by breaking, pulverizing the rock and then displace it sidewise, and because it has a high pressure, it will create its own path, making it bigger and longer and longer and longer. Magma can also use previous cracks, and what it will be is infiltrate in that space up to making it as well wider and then getting up.
Get the camera.
When the wind blows opposite to the direction of the plume, you are safe because the plume and the gases are away from you. But still, several times we have to abort the visit to this station. So, yeah, there is an intrinsic risk to work on a volcano.
And then it is silent. On December the 13th, 2021, the volcano comes to rest after 85 days. It was the longest eruption on the island in 500 years. But it is not over yet. Gases such as sulfur dioxide or carbon monoxide are still deadly sources of danger. A few days after the end of the eruption, Jaime Coelho Bravo visits the crater of the volcano. 3 months ago, the small hill on which he stands was the highest point in the landscape. Both mountains left and right behind him did not exist in early September.
The situation is still dangerous. Although the emission of lava and pyroclastic rocks is over, the gases can still harm our health. And not only at the cone, but in various places that were affected by the eruption. There are places that are impossible to visit because of the gases.
More than 3,000 buildings have been destroyed. The lava has buried about 70 kilometers of road and 370 hectares of banana plantations. For the next few weeks, the invisible gases will still be harmful. Sulfur dioxide and hydrogen sulfide are lethal above a certain concentration. The odorless and highly toxic carbon monoxide worries the emergency workers as well. When will the cleanup process finally be able to begin?
The gas is being released by the magma, but that magma has not completely reached the surface. There are still pockets of magma that are underneath the volcano. And that magma wants to separate its gas, because the gas doesn't want to belong to the magma when it's shallow in the crust, you know, a few kilometers down the surface. So it's going to use all the possible permeable paths, the pathways of the gas to the surface. So if cracks opens, the gas wants to go to the surface, because the surface is at atmospheric pressure. And then we are comparing atmospheric pressure with 10 kilometers depth. That's a lot of pressure, you know? You squeeze something and it goes to where there is low pressure. So the low pressure up, and there is a pathway, which is those cracks, is west, and is producing a lot of degassing.
In the evening, Edgar Zorn and Alina Shevchenko get ready to examine the cracks from the air. Later, they want to use this data to create maps and structural analyses.
This is a thermographic camera that can fly. It takes photos at high frequencies and allows us to not only see where hotspots are on the ground, for example because of fumaroles or magma on the surface, but we can also use it to measure how hot it actually is. Thermal mapping is important because we can see where there is currently still activity, meaning through which cracks heat is rising and which ones are still connected to heat sources in the subsurface.
For 30 days now, the volcano has been still. Felix Medina and Manuel Nojales search for remnants of life in the meter-high volcanic ash near the crater. They walk through a landscape not unlike the moon. Everywhere volcanic bombs lie in their impact craters.
Look at this. They're coming. Many insects are arriving now. Yesterday I read that they are the first colonizers. Most of them come by air. And last night we also found some spiders. In the light of the flashlight, we could see the reflection of the spider's eyes. They probably want to welcome the insects with their webs.
Some birds use the updraft winds above the crater of the dormant volcano. Others never flew away.
I was especially impressed when I saw how big birds such as crows, eagles and kestrels were in the middle of the big ashfall. They were in the middle of it, day after day, right to the end. I was impressed by that. It's fantastic how within 2 weeks they adapted to the new sound and light conditions created by the big lava flow, and how they seem to be right in the middle of it, taking advantage of the thermal updraft. Felix and I kept wondering what they were doing, what all these animals were accomplishing before our eyes in the midst of this real catastrophe.
Jaime Coelho Bravo and Severin Il have climbed the crater edge together.
There are small bombs, different sizes everywhere. See, if you think about the amount of bombs, you know, that fall down, you could imagine how was the process, you know, is every few seconds you have lava bombs, you know, falling everywhere. That's a volcanic bomb. See all the round form, and this is a different one. Fly this way and start to go that way.
Impact crater, right?
Still, it's like a lunar landscape. Have several of them everywhere.
It's alive.
It's hard to believe. It's hard to believe.
These are the epochmic shoots that produce needles from below the bark. Even in the stem. It's a special feature of the Canary pine.
The Canarian pine.
Just 3 months after the eruption, young needles are sprouting on this tree. They're necessary for producing energy.
It's still maybe a little warm.
It's still warm, isn't it?
For millions of years, the Canary Island pine has lived among the volcanoes. This perfectly explains how well adapted the pine is to the volcanoes of the Canary Islands.
Surprisingly, the bark isn't too burned. Pine forests are burned black after a fire, but this looks surprisingly healthy and burned only very little, even though we're only 50 meters away from the volcano.
Yeah, it's because the volcanic gases just push away the oxygen. And you know that for the fire to occur, you need certain level of oxygen that was not possible to get because of the volcanic eruption.
So the volcano prevents the forests to burn, prevents fire.
A strange idea, isn't it?
Yeah, it's really...
It's a small insect here. Could you see it?
Life is returning.
Yeah, life is returning.
Life is returning. A story of destruction and evolution. A story about volcanoes.
This volcanic eruption reminds us how extreme the living conditions on our Earth once were, and how it nevertheless became more and more populated by plants and animals. It reminds us how, in the course of evolutionary history, natural catastrophes have repeatedly caused the extinction of entire groups of living beings. At the same time, other creatures were given the opportunity to populate the niches with new forms of life.
In each case, a new geological epoch arose. A catastrophe is also a chance for the life of other groups of animals and plants, which will prevail until the next catastrophe comes. And then the same thing will happen again. This is undoubtedly the great lesson that the volcano has taught us.